Hey everyone, so as you might know with ConnectFEA, you can pretty much model any parametric steel or steel concrete connection, run analysis, and then push it through some design checks. I thought today I'll take you on a quick tour drive and show you what it looks like in the most recent update, Beta 2, and some of the cool stuff you can do. So we'll build a new model from scratch using the input workbook that you see there on the left. And I'm just quickly defining some profile members, pulling information from my section database, and specifying the start and end coordinates and materials and visibility and stuff like that. And you'll notice the input workbook functions the same way as any spreadsheet component, such as Microsoft Excel, for example. So that means we can use formulas and set things to link to certain properties of other things. So right now, we've created a profile and we've added a plate element, and I'm now in the bolts sheet. And I'm defining a bolt member here. You can see there I've set the diameter to 20 millimeters. I've set my start XYZ coordinates. I'm specifying the material there and the visibility. And for the end XYZ coordinates, I've entered some values and set some of them equal to the other ones depending on the local axis of my members. And you'll see there on the screen, when we enter new profiles, it'll add additional geometrical properties that we can link to. So that plate, for example, I'd like to connect that, flush with the web of that main member there that runs across the y-axis. So what I'll do is I'll use the formula bar there to offset that plate half the width of the web in the positive X direction, and that's going to position it for me perfectly. And then I'll use the depth of that beam, and I'll just subtract a fixed value as an example from that to create the height of the plate. And that'll mean that things line up quite nicely. And lastly, I'm just going to specify the length of that plate, make it a little bit thinner, like 150 millimeters, or perhaps 175 would work better. You can build in your own formulas there. Anything you can do in Excel, you can do here. It can be if statements. It can be complex formulas. You can go crazy pretty much. Next, I'm going to now set up my bolt so that the end of the bolt on the left-hand side, so where X is smallest, is going to perfectly line up with the outer face of the web of that beam, as you can see there. And again, I've used the parametric properties. I've said that location of the bolt, that P1, X location is equal to half the width of that web in the negative X, and that lines up perfectly. And for the other side, we said, let's make it half the width of the web plus the thickness of the plate, meaning if we change the thickness of the plate or the member profile for that main member and the web thickness adjusts, then our components are going to be dynamically adjusted as well. And then I'll just copy that bolt across and use some of those properties to create my top row and my bottom row and complete the rest of my bolts. Again, I'm setting some values equal to the other ones so that if I make a change like the diameter or the positions along the Y spacing and the Z spacing, that it's easy to just quickly update one and that'll update all. Then I'm using the machining tools here to cut that or trim that beam element back to the plate so that it connects nicely. And you can see there, ConnectFEA picks up those faces with its subtractions of the bolt elements automatically. And while I did that, I noticed I made a little bit of an error in one of the formulas there for the bolts. So I'm quickly going to fix that up so that they align nicely, so that the nut or the head of the bolt there aligns nicely with the front side of that plate properly. And we can see that's now nicely aligned in different views there, so everything looks pretty good and matches up as we expect. So next, I'm going to tie elements together. So we're going to use the weld tool to connect the end of that profile, the incoming profile, to that end plate, and then we'll set up some contact elements. So we'll use the contact tool to specify the contact mechanics between the plate and the web of the beam, and then we're going to use the auto bolts tool to do the same thing, but for all the bolts where we've got the shafts interacting with the holes and then the heads and the nuts of the respective faces of the plates or the profiles. Once we've got that all sorted, we can go ahead and apply our supports. So we'll specify fixed supports on both sides of that beam, and then we're going to apply a uniform load of 115 kilonewtons on the top of that beam. Now that we've got all of that done, perhaps a good time to go ahead and save the model. So we'll just save this, and then we can have let's have a quick look at the settings, the analysis settings and the application settings. So we're using the Pardiso solver here from Calculix, and we're running 12 CPUs on my current machine, or 12 threads actually. I've got 12 CPUs, so we can do 24 threads, but in this case, I just set it to half, so that's fine. You can see the mesh factor, the minimum and maximum mesh sizes, and the optimization and refinement and smoothing steps that we've set there by default, just to help us get the optimum kind of mesh quality output. Of course, you can set that coarser if you want, but that's kind of the optimum settings that I prefer. Then we run through the analysis process. You can see it there stepping through, creating the mesh, discretizing the elements, mapping up faces, doing the contact mechanics and loads and all of that. It runs through the analysis. It takes about 2 minutes. I sped it up. And then when it's done, you can see the outputs there. So it gives us this really great graphical output. It defaults to displacement. And you can see that we can actually switch on and off various members there from the member list. And it also gives us a quick overview of the maximum stresses and the capacities of those elements. This is not a design check. This is just a quick visual check to show us the outputs and some initial guess values. Of course, we can do a bit more with the graphics output. We can set the exaggeration of the deflected shape, and we can toggle that to different values, obviously, and switch different outputs, whether it's displacement in different directions, or all directions, or stresses, or forces, and so on and so forth. Once we've got all of that, we can plug it into the calculation engine or design pad, which is a modified calc pad variant that we use, and it'll give us a summary of the elements with their utilization for tension and shear, and then it'll do a detailed calculation of each member, the bolts, the plates, the profiles where the bolts interact with them, and show us in detail using a calculation template on whether those pass or fail the checks that we've set up here. And you can, of course, customize those calculations to suit your own narrative and your own outputs and criteria that you want to check. But by default, this is what it does. It does quite a lot of work, and it presents really well. So let us know if you want to give ConnectFEA a try. Cheers, bye.